Welcome to this explainer. We are diving straight into something that is honestly just fascinating, a really poetic connection. We're going to look at how the rigid, super complex architecture of artificial intelligence actually perfectly mirrors the fluid beauty of mathematical paradoxes. And, ultimately, how all of this relates to the chaotic ways our own human minds work.
So, think about a storm for a second. Can a machine, something built entirely on cold, hard code, ever really understand the poetry of a hurricane? When we look at advanced multimodal AI, like Gemini 3 Flash, we aren't just looking at a glorified text processor anymore. We're looking at a system built to digest the literal chaos of the real world. But how does it actually make sense of something so visceral?
Well, think of it like a journey. When you hand an AI a prompt, it doesn't just swallow it whole. It shatters your input into manageable little puzzle pieces. That's a process called tokenization. But it doesn't just look at those pieces in a vacuum, right? It loads up the context window, remembering the whole conversation you've been having. Then comes the really heavy lifting, the forward pass. This is where those tokens travel through massive layers of self-attention, weighing billions of probabilities just to figure out what matters most. And finally, generation. It predicts the very next piece of the puzzle, one logical step at a time.
Now, what's really wild about a natively multimodal AI is how it digests entirely different slices of reality. It doesn't do that clumsy thing of translating a picture into text before reading it. No way. Instead, text becomes subword embeddings. An image? That gets sliced up into a grid of spatial patches. Audio waves turn into spectrogram tokens, and video becomes these 3D blocks of time and space. Literally, every sense is mathematically chopped up into its own native language.
And here is where the magic happens. All of these different mathematical units are projected into what we call a shared latent space. You can think of it as a universal translator. In this crazy, high-dimensional realm, the word sunset, a photograph of a sunset, and the literal sound of crashing waves, they all end up mathematically sitting right next to each other. This is exactly what lets the AI seamlessly jump between a text query and visual pixels to find your answer.
But okay, to process all those sights and sounds at such a massive scale, we actually have to rethink how computers count. Most of us, we grew up visualizing numbers kind of like a calendar, pages of 100 entries moving in a straight linear line. But AI runs on binary, so I want you to imagine an infinite branching tree. You start at the root, a 0 means go left, and a 1 means go right. Every single time you drop down a level, you literally double the size of the world you've just built. And because of this branching structure, infinity isn't some far-off destination the numbers eventually reach. It's really just the limit of the container they're stored in. So when a computer breaks near infinity, it's usually just that container overflowing. Imagine a digital calendar that only has 8 slots. Once you hit the maximum, it just wraps right back around to 0. The math itself isn't breaking. The jar just got way too full.
But just as we get comfortable with that math, boom, we hit a philosophical glitch that completely shatters these rigid systems. It's known as Russell's paradox, discovered by Bertrand Russell back in 1901, and it is basically the glitch in the matrix for formal logic. It asks us to imagine a list of all lists that do not contain themselves. Okay, stay with me here. Does this new list contain itself? If it does, it violates its own rule. But if it doesn't, then by its own definition, it has to be on the list. It creates this terrifying, endless, infinite recursion.
To put it simply, if a system tries to define itself by its own contradictory rules, it's trapped. It traps itself completely. Russell famously used the barber paradox to explain this. Imagine a town with one barber, and this barber only shaves people who do not shave themselves. So who shaves the barber? If he shaves himself, he breaks his own rule. If he doesn't, he's forced by the rule to shave himself. If an AI acts as the set of all books, but is also somehow a book itself, it hits this exact logical wall and just crashes into an infinite loop.
Now, this paradox of self-reference actually perfectly mirrors the beautiful chaos of our own minds. Think about how we, or an AI for that matter, actually think to solve these kinds of loops. We use divergent thoughts, which are expansive associative searches, kind of like pulling loose ideas for a poem. And then we use convergent thoughts, narrowing down those probabilities to find one single logical solution. We are constantly balancing strict symbolic logic with raw, unspoken subsymbolic patterns. Basically, we feel the vibe before the words even form.
So how on earth do we actually solve Russell's paradox? How do we stop the whole system from just totally crashing? Well, we add a brand new dimension, time. In a static world, a container cannot contain itself. But the moment you add time, everything changes. At time 0, a seed exists. At time 1, the tree exists. At time 2, a new seed exists. The tree and the seed never ever occupy the exact same moment.
Time essentially acts as the ultimate separator. It means the system doesn't crash into a loop because it exists as a continuous, flowing process of growth. Think about it. You are not a fixed set. You are a process. If you sit down to write a memoir about yourself, you are both the author and the subject. But it isn't a paradox, right? Because the you writing the book today is separated by time from the you who actually lived those events. Time literally unrolls the recursion.
And to map this dynamic reality inside an AI, engineers rely on highly specialized temporal data structures that are designed to only ever point forward. Whether they are mapping out future possibilities in complex industrial robotics or just predicting the next word in a text, they use structures like directed acyclic graphs, pathways where the connections literally only move into the future. This guarantees that a prediction can never travel backward to change its own origin. It safely avoids the paradox altogether.
Let's actually look at one final, absolutely beautiful example of this concept. Take a look at this paradoxical equation. A equals -1 divided by 1 plus A. Now, if you try to solve this using standard algebra on a normal number line, you're going to hit a brick wall. The math simply breaks. There's literally no real number that makes this equation true.
Because it constantly refers back to itself, this equation creates a divergent infinite series that violently shakes from side to side without ever settling down. It's essentially an unstable control loop, endlessly hunting for a perfect balance that simply does not exist on a flat, one-dimensional number line.
But what happens if we give the math a second dimension, a real game changer? By introducing imaginary numbers, we add a vertical y-axis. Suddenly, that erratic signal that was violently bouncing back and forth on a flat line now has room to rotate. The paradox doesn't crash the system, it gets absorbed into a beautifully stable, perfectly circular, two-dimensional orbit. Which brings us right back to where we started. What looks like a completely chaotic inner hurricane from one limited angle is actually a picture of perfect mathematical stability from another. From the ground, the winds of a storm contradict each other, blowing in totally opposite directions. But if you zoom out, if you add a dimension and view it from above, you see the rotation. It isn't fighting itself anymore. It's flowing.
As we wrap up this explainer, I really want to leave you with this thought about the hidden structures that govern our technology, and honestly, our own minds. Whether it's the complex multimodal pathways of an AI, the forward march of time resolving a logical paradox, or imaginary numbers turning a crash into an orbit, the universe just has a way of balancing itself out. So when you face a paradox in your own life, do you really need to fix the system, or do you just need to add another dimension to see the rotation? Thanks for exploring this with me. Keep wondering.